Welcome back. Let's take a look at another rate of change application. This dealing with baseball. The distance from the pitcher's mound to home plate is 60 feet 6 inches. The pitcher throws a fastball 90 miles per hour. How many seconds does the ball take to travel from the pitcher's mound to home plate? Okay, here we're given the velocity or rate of change, and we're asked to find the variable time. We're asked how many seconds does it take. We'll need to convert our units for time and distance, but for now let's just convert distance since we're given this information, 60 feet 6 inches. Our velocity is in miles per hour, so let's go ahead and convert our distance to miles. So let's do this. We have 60 feet 6 inches, and we can rewrite this as 60.5 feet because there's 12 inches in every foot, so 60 feet 6 inches is 60.5 feet. Alright, and we know that 1 mile, we're converting to miles here, feet to miles, 1 mile contains 5,280 feet. Okay, when we're converting smaller units to larger units, what we're going to do is we're going to divide. So we're going to have 60.5 feet divided by the 1 mile equivalent, which is 5,280 feet. Okay, these units cancel, and we're left with 0.0115 miles. Okay, so the distance from the pitcher's mound to home plate is 0.0115 miles. Now we're just going to leave it like this for a second because our time is in miles per hour, so we need to deal with similar units before we convert at the end. So now we can set up our formula for rate of change. Now what we're looking for here is how many seconds does the ball take to travel from the pitcher's mound to home plate. So we're looking for time. So we're going to let t equal time. And this is going to be in hours. Remember, we're working with miles per hour right now. So we have our distance converted into miles, so we're going to have our time be in hours. So let's go ahead and set up our equation. It's actually going to be a proportion because we're going to be comparing one velocity to another. So let's see, we have 90 miles per hour. We're going to write it as a fraction, 90 miles for 1 hour. And we're going to have the change in y over the change in x in our pitcher's problem. So we have 0.0115 minus 0, we have an original distance of 0. We're starting from the beginning, and we went this far from the pitcher's mound to home plate, and now the change in time. We have time t minus 0. We started originally at time of 0. This is in miles. This is in hours. Okay, so let's go ahead and subtract this out, even though it's kind of a moot point. 0.0115 minus 0 is 0.0115 miles divided by t minus 0 is just t, and it's given in hours, so we actually don't even need to write hours. Our time is going to be in hours. And now we can simply solve for t by cross multiplying. We should know how to solve proportions. We did a whole section on them, so go back and review those in case you need a refresher. We have 90t equals 0.0115. And we can solve for t by dividing both sides by 90. These two terms cancel, which gives us t equals 0.0115 divided by 90 gives us 0.0001278 hours. Okay, it's a really, really small number, so we want to take all the decimal places that we need to. This is the amount of time that in hours that the ball takes to go from the pitcher's mound to home plate. Okay, so all we need to do is convert our answer from hours to seconds. Since it's such a small fraction of time, we want to give it in seconds, which actually will make a little bit more sense because not too many people think of this span of hours. So when we're converting larger units, hours, to smaller units, being seconds, we're going to multiply. So let's take 0.0001278 hours, let's go ahead and convert it to minutes first. We're going to multiply that by 60 minutes, because there's 60 minutes in 1 hour. 60 minutes per 1 hour. Hour cancels with hour, which gives us 0.007668 minutes. This is the equivalent of how many minutes it takes for the pitcher's mound to get to home plate. Now we want to do one more conversion, convert minutes to seconds. So we have 0.007668 minutes, and we're converting it into another smaller unit, so we're going to multiply again. 60 seconds is in 1 minute. Minutes cancels with minutes. Multiply this number and 60, and that gives us 0.46 seconds. So it takes, and that's our answer, it takes 0.46 seconds for a 90-mile-an-hour fastball to go from pitcher's mound to home plate. So just under a half a second, and it's a pretty short time. So just follow this again, review this, and just notice that we go from step to step in our rate of change. And the biggest problem we have here that we have to deal with is just converting our units. So we're just going our distance divided by our distance here, which is the really important part, setting this up, and then the rest is just converting. So review this a few times, make sure you understand it, and I'll see you soon.